Real-world computer programming for kids of all ages. Step 46. Designing, explaining, and creating our main database table. Hello out there. We have learned about SQL and its siblings, DDL and DML. We have created a table, states, populated it, and updated its data. Frankly, though, what we did with the states table, we could have done with a database intended for use by a single person, such as Microsoft Access, rather than a full-featured multi-user database such as the one we're using, MySQL, or Firebird, or MS SQL Server, or Oracle, etc. We now want to discuss some of the basics of relational database design. We spoke earlier about how DBMS stands for Database Management System. Now we move into RDBMS, which stands for Relational Database Management System. Note, I do not hate Microsoft Access. It's just fine for what it is, a hobby database. Go ahead and use it to store data about your comic collection or stamp collection or coin collection or even data for your business if you will be the only person using it. Or it will only be used on one machine and you back it up regularly. But Access was never intended for use as a serious database and should not be used as such. This is not to say that people don't do that, they do. But it's like trying to hold together a complicated machine with moving parts using duct tape and silicone. It will work okay under some circumstances, but if you put enough pressure on it or stress on it, collapseville. If you like Microsoft Access but need something more heavy-duty, give Microsoft SQL Server a try. I heartily recommend it, as I do Access, for hobby projects. So what is this relational jazz we've been talking about? What does it relate to? How can a database be related to something? In what way? You are probably not shocked that I'm now going to tell you. And it shows a picture of a couple of people who are looking quite shocked. We briefly discussed a relatively simple example in the last step with a fictitious users table and users entries table. That was just to whet your appetite for learning about relational tables, as the subject was presented in such an alluring manner. But we will leave that example be and move on to a new set of tables based on movies. First, though, a word or two or so about how it is that tables can be relational. In designing a database, which normally consists of multiple tables, we want to keep in mind the dry programming principle. Don't repeat yourself. It saves time, it saves space on the disk or on the network server, and ultimately saves a lot of frustration if you practice dry by what is called normalizing your tables. Note, the database term normalize is, in my opinion, a misnomer. What is meant by that word is designing your database in an efficient manner. But is that normal? I don't think so. It's more normal or common to design them in an inefficient manner. I don't know what the word should be, but normalize is misleading, methinks. To understand what is meant, it is probably helpful to view a bad example of table design. Since we are going to build a database, a set of related tables, about movies, flicks, films, whatever you want to call them, let's use that as an example. Say you wanted to store information or data about movies in a table and design it like the following. Then it shows a table named Movies with these columns: Movies ID, movie name, MPAA rating, star rating, movie length, genre, director, screenwriter, actor 1, actor 2, and actor 3. Can you see any problems with this structure? Before we revisit that question, here's another look at that structure with comments explaining what the columns are. Movies ID, this will be an auto-incrementing value starting from 1. Movie name, self-explanatory probably, the title of the movie. MPAA rating. MPAA stands for Motion Picture Association of America. The ratings they designate are, for our purposes, G, PG, and PG-13. Star rating. This is the degree of critical or public acceptance of a movie, usually ranging from no stars, an unmitigated train wreck disaster of a film, to 5 stars, a don't miss it masterpiece. Movie length of the movie in minutes. Genre, this is sometimes nebulous, but typical genres are comedy, drama, documentary, slice of life, coming of age, or combinations of these such as dramedy, drama and comedy, mixed, etc. Director, the cat or chick who directed the flick. Screenwriter, the cat or chick who wrote the screenplay, the dialogue. Actor 1, the main actor. Actor 2, the second highest billed actor. Actor 3, the third highest billed actor. As an example of what a database record with these columns would look like, here's an old favorite with data based on imdb.com's webpage on it. Movies ID is whatever the value is at that time. Let's say 1. Movie name, The Princess Bride, MPAA rating, PG, star rating 8.1, and this is out of 10 on IMDb. Movie length 98, that's minutes. Genre, adventure, family, fantasy. Director, Rob Reiner. Screenwriter, William Goldman. Actor 1, Cary Elwes, who played Wesley. Actor 2, Mandy Patinkin, who played Inigo Montoya. Actor 3, Robin Wright, who played Princess Buttercup or the Princess Bride. So what is the problem, or what are the problems with this table design? One thing is, I already see that the star rating column should be a float data type, not an int, because even though a typical rating in a newspaper or magazine review runs from 0 to 5 stars, IMDb's ratings are more granular and go up to 10. And not just in whole numbers. You see that The Princess Bride has received 8.1, so we need a real number with decimals to record that value. A bigger problem, though, is the listing of actors, and director too, but we'll get to that presently. Specifically, the problem with having 3 actor columns, actor 1, actor 2, and actor 3, in your table is that you're not only going to have some wasted space at times, such as in a movie with only 2 main actors, for example, My Dinner with Andre, thus resulting in an empty actor 3 column, but you will also often have to leave out other important actors if you're only recording 3. Take the movie used above as an example, The Princess Bride. Look at the list of the cast below from IMDb's page and, presuming you've seen the movie, tell me which of the 13 actors or characters listed there did not contribute greatly to the movie. And then it shows a screenshot of that listing from that page. Can you imagine the movie without Andre the Giant or Fezzik or Vicini or Miracle Max or The Grandfather? And that's just for starters. So the actor 1, actor 2, and actor 3 columns have to go or be changed. Besides, don't they violate the dry principle? If you retained those columns, wouldn't you have many movies with the same names stored in those columns? John Wayne, Joan Fontaine, Robert De Niro, Meryl Streep, Tom Hanks, Helen Hunt, David Strathairn, Robin Wright, Chris Cooper, Saoirse Ronan, Michael Shannon, Emma Watson, Benedict Cumberbatch, Florence Pugh, etc., ad infinitum, ad nauseum. We'll solve these problems and others in the next step, but before we get to that, we have to create the foundation, the main table. The movie main table, designed and explained. To cut to the chase, this is what the movies _main database structure should be, with the now deleted columns stricken out. So it shows the same ones we had before, but 3 stricken out, 4 stricken out. Genre, actor 1, actor 2, and actor 3. So that it is now, after being normalized, and it shows that same listing, but with the stricken out ones left completely out. And movie name has changed to movie title, and star rating has changed to IMDb rating. Note, I changed the name of the star rating column to IMDb _rating, since we are going to be using IMDb's more granular and democratic value. I say democratic because its rating is based on an amalgamation of movie viewers' ratings, not that of a single, or possibly married, professional movie critic. I also changed movie _name to movie _title. It just seems a little more accurate. Now I will explain why the movies table is structured as it is. The movies _main table, that is. Because of the other related tables we will be creating, the movies _ID column is more valuable than ever. You'll see why. The rest of the values are specific and unique to this movie. However, remember the warning that the word however carries with it. None of these values are truly unique. For example, there are several movies named Missing. The one with Jack Lemmon and Sissy Spacek is great. Many movies share the same MPAA rating, of course. Also, many share the same rating on IMDb. Many movies are of the same length. 96 minutes is a popular duration. Many have the same directors, such as David Lynch or Greta Gerwig or Spike Lee or Terrence Malick. Many movies have the same screenwriter, such as William Goldman, who wrote the screenplay for Butch Cassidy and the Sundance Kid, All the President's Men, and The Princess Bride. Or Dalton Trumbo, who wrote the screenplay for such movies as Roman Holiday, Spartacus, The Sandpiper, Johnny Got His Gun, and Papillon. But collectively, this is a unique record. For example, if one movie has the same name or title as another, it is highly unlikely that it also has the same director and screenwriter, or that it has the other values in common for that matter. That's why the movie _ID column is vital. It uniquely points to this record. No two records will contain the same movie _ID value, so that column holds the unique identifier for any particular movie. Note, speaking of Papillon, it reminds me of the only word I know in 5 languages. It is butterfly in English, Schmetterling in German, mariposa in Spanish, papillon in French, and Utterfly Bay in Pig Latin. Or should it be called Pig Latin Pay? Anyway, we are ready to add this first main table to our movies extravaganza, or collection of tables, or database, I guess I should call it. Let's do that. Here's a final listing of that table along with its data types. So movies main table, movies ID is an int and an auto inc value and the primary key of the table. Movie title is a varchar 50, MPAA rating is a varchar 10, IMDb rating is a float, movie length is an int, director is a varchar 50, and screenwriter is a varchar 50. Now follow these steps. 0. In DBWB select file, create new database. 1. Select the next button in the create new database wizard dialog. 2. In the database name edit box, enter movies. 3. Select the finish button. 4. Beneath schema, movies, right-click tables and select new table. And then it shows a screenshot of what you need to do there. 5. Remembering to click the add column icon after adding each column in the design area. Add all the columns listed above so that it turns out like this. And it shows a screenshot of what it should look like in DBWB. The DDL tab should now look like this. And it shows a screenshot of that. 6. Add a value in the table edit box above. Let's name it movies _main. And it shows a screenshot of that. Note that the table's count on the left is still 0 at this point. 7, click the create/alter table icon, and it shows a screenshot of that icon so you can know what it looks like and where it is. 8, confirm your intention by selecting the yes button in the confirm dialog asking create new table. DBWB wakes up the gerbils. They get up and spin their wheels for a couple of microseconds, and wallaby. As you can see now, the new movies _main table has been created, and it shows a screenshot of that. That's the start we needed. In the next step, we will add the ancillary or helper/sibling/cousin tables that will make the whole thing work. Until then.